Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. I'm Cadet Rizka Dewi MTU from Diplomatry Air Transport Management, that's Delta, Aviation Polytechnic of Surabaya. Case number 3062296. Okay, well, today we will explore about climb and distance aircraft. We will learn about how aircraft descends and how aircraft climb, load factor, and yeah, we will learn about them. Okay, let's start. First, I will tell you about climb phase. Well, climb starts after takeoff and it ends when aircraft levels off at the cruising level. Aircraft can climb only if it can produce excess thrust. Well, thrust minus drag. And this excess thrust needs to offer contrast. For example, if an aircraft is producing 1,000 pounds of thrust and has 700 pounds of drag, it will have 300 pounds of excess thrust available. As you can see at the right corner, the first step, there is climb and accelerate to climb CAS. CAS is constant airspeed, and then second, it become climb at constant CAS, and then it become climb at constant mass. Match is the ratio of aircraft speed to the speed of sound through the medium where the aircraft is traveling, and it will become accelerate to initial cruise mass, and last it will cruise at initial mass. Okay, next we have factor that affecting the climb performance. As we know at Mr. Danny PowerPoint, there are 5 factors. First, we have speed and acceleration. Well, it is required for the acceleration because there will be less excess thrust and therefore reduce the angle of climb. And the second, we have aircraft mass. Increased mass give higher drag, which reduce the excess thrust, the difference between the thrust and drag, and therefore reduce the climb angle for a given thrust and reduce the rate of climb. Third, we have temperature and air density. The higher the air temperature, less thrust can be produced by the engines. So because of that, the difference between the thrust and the drag during the climb is smaller. Therefore, the climb gradient and the rate of climb will be reduced. Four, we have wind. Wind condition, headwind or tailwind will have effect on the aircraft ground speed. So a headwind will reduce the ground speed and therefore reduce the horizontal distance that an aircraft travels in compressions. No wind condition, so therefore headwind gives increased climb angle. And last, we have restrictions of flap and landing gear. When the flap and landing gear are restricted, the drag is reduced, resulting in an increase in excess thrust. Therefore, the rate of climb is increased. Now we move to the questions. How aircraft descends? Well, descents start at the end of airspace and it ends when aircraft will start approach for landing. Aircraft descends by reducing thrust or engine power. This reduces aircraft speed, thus creates less lift. So the airplane slowly lowers, decreasing altitude. So for climb aircraft, we have to produce excess thrust minus drag, right? But for this distance aircraft, we have to produce excess thrust or drag minus thrust. Next question is how to determine the top of distance point. Why? It's important to calculate it. A very simple formula for determining TOD. TOD is top of distance point is distance plans mean that the aircraft will require 3 nautical miles distance for every 1,000 feet of aircraft altitude above ground. For example, aircraft cruise at flight level 300 with destination airport at sea level. Okay, so 3,000 feet, 30,000 feet, 30,000 feet divided by 1,000 feet equal to 30. And then this 30 multiples by 3 nautical miles because 3 nautical miles distance for every 1,000, right? So after we multiply it is equal to 90 nautical miles. So it means that 90 nautical miles is required for that distance. Okay. Now why it's important to calculate. Well, because of the crew, the flight crew have to ensure that they arrive at the correct level for the start of their approach. Next, we have why it is important to consider distance gradient and rate of descent. There are three reasons. And then first, we have two. The reason is to reduce distances, reduce fuel consumptions. The second is to ensure rate of descent, rate of atmospheric pressure changes proportional to the rate of change of the cabin pressure. Note that rapid descent can cause trapped gas in the middle air block. Third, we have to know that the reason is to ensure the safety of aircraft and passengers. Well, the rapid descent also can cause aircraft loss of control, and this can lead to the crash. Okay, next we have factor affecting descent performance. In the previous slides, we have a factor that affecting climb, and now we have a factor that affecting distance. Okay, first we have speed. Speed is in general, rate of descent increases with increasing speed and increasing drag. Optimum speed requires for the best descent performance. Second, we have wind. The distance angle relative to the ground will be affected by the wind. Wind affects the ground speed, so the distance gradient will be affected as well. Third, we have aircraft configurations. Aircraft configuration, flap or landing gear affect the aircraft lift and drag. The total drag of an aircraft will depend on its configuration. Fourth, we have cabin pressure ratios. So the rate of change of the cabin pressure has to be proportional to the rate of change of the atmospheric pressure, rate of descent. So the cabin pressure has a greater effect on the rate of descent in comparison to the rate of climb. Okay, I think that's all about descent and climb of an aircraft. So may that give us a lot of knowledge and increase our knowledge. We can learn together. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Have a good day.